Alright, I want to show you what a normal distribution is all about in statistics. And there are three things that should come to mind when you read the words normal distribution. The first thing is that you have what's called a bell-shaped curve that basically looks like this right here. It's bell-shaped curve. Okay. That means that the mean, which is kind of sitting right here in the middle, has the most data that's sitting around it on either side of the mean. I'll talk a little bit more about that later. But definitely bell-shaped curve is one of the first things that should come to mind when you read that word normal. The second thing that should come to mind when you hear normal distribution is that the total area under the curve is equal to 1. So all of this area underneath this bell-shaped curve, all of it, including everything out here in the tails as they get smaller and smaller, is a total area of 1. And there's one more thing. The third thing that should come to mind is that this bell-shaped picture here is symmetrical. Right? It's symmetrical. And that comes into play and is very handy. It's kind of a geometric term for later problems. So if I was to kind of split this thing right down the center here, you would see that half of this picture over here, if the whole thing is 1, is 0.5, and the other half is 0.5, giving you a total area, everything from here all the way over to here. Right, total area all together, everything under the curve here, that gives you a total area of 1. So those three things should come to mind when you hear the words normal distribution. It's bell-shaped, total area is 1, and it's symmetrical. Let me just go one more step and show you what I mean by, and perhaps you've seen this as well, not only are we talking about now a normal distribution, but something called a standard normal distribution. So a normal distribution, again, are these three things, right? Bell-shaped, total area is 1, and symmetrical. Standard normal kind of uses these three things but kicked up one more notch, and two other things, we'll mark them 4 and 5, how's that? Two other things should come to mind when that word standard is used, right? Two other things should come to mind. Number one is that the mean, and that Greek letter is mu, which stands for population mean or population average, same thing, that the mean is going to be a 0. All right, that's what standard means. Standard means that the mean, population mean, is 0. And the other thing that it means is that this Greek symbol sigma, which is lowercase sigma, and that means population standard deviation, is automatically 1. So these two things are also part of what the standard normal distribution areas. Right? So there's normal distribution, which means these three things. We covered those a second ago. But when you read the word standard normal, these two things also come into play, which means, going back to this picture here, that the mean sits right here in the middle, is 0. The average is going to be 0, and that one standard deviation, right, one standard deviation in either direction is also into play. So that's what we mean, and there's this other idea called the empirical rule, but we can get into that another time. 68% of your data is sitting smack within one standard deviation. But this is what, just a real rudimentary level of what we mean by a standard normal. Means that the population mean is 0, population standard deviation is 1, and when we say normal, we mean it's bell-shaped, total area is 1, and it's symmetrical. Hope that helps.